I just want to tell everybody that all these presentations and assignments are basically there in the Google Classroom, and I believe that Sharad sir has already uploaded it, and all the students, all the faculty members will be getting this particular presentation and this assignment which is there. I request you all to go ahead and revise these presentations and remember these assignments that you have done during this course. This will help you to answer the questions that most of the companies ask you, and that is very useful for the next, at least for a decade or 2 decades, that is for the next 10 to 20 years. And you should do it, you should keep on revising these particular presentations plus the assignments that you have done. And remember one thing, although one among the students is presenting, it is very necessary that everybody pays attention to that, what your faculty member is guiding you, and you should be thorough with that particular assignment. And we have done assignment of supervised, unsupervised, and we have also done an assignment in which we have used collab, that is, we have used deep learning. So I request you to be very serious about this particular assignments that you have done, and all the PPTs are there with you, and you should revise it before you appear for any interview with the companies. Can we start now, madam? Hello, madam. Hello, sir.
Sir,
Yeah,
hello.
madam. Can we start now?
We start now, sir.
Okay, wonderful. So we will go with this presentation till 10:50, and I request you that any questions that you may have starting from the very beginning, you can ask at 10:50, and subsequently today's lecture, we are going ahead. Very good morning to one and all, and thanks for attending this AI&ML session. Today we will be dealing about the recurrent neural network, and these recurrent neural networks are very helpful in the analysis of the handwriting, typically the text which is there, and that is where we will deal with RNN. Last lecture, we dealt with CNN, which is convolution neural network, which we have used for the analysis of the images. Today, RNN, and we will see this particular agenda of a vendor architecture, and the extension of RNN is long and short-term memory, and the GRUs, graphic processing unit, and there are various applications. Now, first of all, when we are learning about recurrent neural network, it is very necessary that we should know Why we are learning? We are learning it so that we can analyze the text and the handwriting, and we need to go backward and we need to go forward and then analyze the particular signature or the handwriting that we have written. The math for this is derivative of the particular L letter language that's coming in. And when we are taking the derivative with respect to the weights, and you can see that all this gets cut off, and we are left with the derivative of language and divided by the derivative of weights. This also follows the particular deep learning in which there is a input and there is output and there is a lot of hidden layers. If it is a single hidden layer, then we will say that we have one hidden layer, or we may have more than one hidden layers also. Now, what we supply to the input of this particular recurrent neural network is basically a sample at a time, and this sample is of the fixed length that we are having. Now, this, for example, is the handwriting that is being supplied to the recurrent neural network, and it is the duty of the recurrent neural network to learn from this handwriting. And once it learns from this handwriting, it is basically very easy to go ahead and identify what letters are coming in, and then to go ahead and for this network to identify the letters that are coming in. So we are training the recurrent neural network by giving some of the handwritten, for example, text which is there, and it is identifying that and learning from this particular text that we are doing. For example, if it is even a signature that a person has done, it is very easy for the network to go ahead and learn from this signature, and then subsequent signatures which are coming in. When we pass it to the network, it is very easy for the signatures to be identified by the network and say whether that signature belongs to the particular person or not. Now, we are using RNNs or the recurrent neural networks, and these are intelligent systems. These are the networks that need memory. And you can see out here that many inputs which are there are sequential, and that is the reason we use this particular recurrent neural network. And we have some dependency, like for example, if we take a particular sentence or a particular signature, we have dependencies at the back which are basically to be analyzed by this particular network. And when we are using this particular recurrent neural networks, we are basically going a particular step, one or two steps backward, and then we go ahead and try to identify this particular signature or this particular text. But when in the case of CNN that we have learned last week, we do not have any cycles. But in the case of RNN, that's the recurrent one, we have to basically go back and we have to analyze what has been written at the back, and then we have to go ahead and frame the complete sentence or the signature per se. This is basically the architecture of a recurrent neural network, in which the recurrent neural network has to go back and forth, and then it has to analyze the particular sentence or the particular signature. Now, what we are doing with the sequential data, we basically turn an input sequence into an output sequence. and then basically we go ahead and identify the particular sentence or the particular signature. For example, a sequence of sound pressure to a sequence into a sequence of words which are there. This recurrent neural network is basically going to analyze that. We can also analyze the sequence of images and the sequence of words. We can also do the language translation. In a while, I'll show you the example how the recurrent neural network is basically going to go ahead and analyze this particular sentence. What the recurrent neural network does is basically learns a model, and this model is helping in predicting the next term in the input sequence. For example, predict the next word in a set of words. For example, if we just skip to the network, you use this on a everyday basis, or we give, for example, stock market time series data. We, as you know, for example, the stocks keep on changing every day, and this recurrent neural network is going to help us analyze that. We are also going to predict the next term in the sequence, and then this is done by the help of recurrent neural networks. We also use this particular method, and this is for the both the supervised, but doesn't require a separate teaching signal. That means we have to basically go ahead and train our network only once. For example, take this particular sentence: a horse carrying a large load of hay and two people are sitting on it. This is basically the image that is basically displayed to us, and then the recurrent neural network will basically learn that, and it is very easy that if the next image is shown with the horse carrying the hay, it will be able to say that this particular image belongs to the horse carrying a hay. Now, not only recurrent neural network is used for the images along with CNN, it is also used in many of the natural language processing tasks. And for example, if it is a time series data, for example, the data about stocks, it is very easy for it to identify, or the weather. For example, a stock or a weather will change with respect to time, and it's very easy for the recurrent neural network to go ahead and identify what are the changes which are there, and then go ahead and basically give us the output. We got to basically also do speech recognition, the recognition of the particular speech, or translating a particular sentence from one language to the other. And for all of this, we basically use recurrent neural network. And we also identify the sentiment which is associated with a particular sentence. And this all can be done using the recurrent neural network. Basic architecture, we have discussed about it, and what we want to say is that basically the loop which you see of the weights which is there are basically being executed again and again, and it is very easy that we go back and forth, and then we analyze the particular meaning of the sentence which is there. And for analysis of this, the recurrent neural network is basically very important, and this is basically the architecture of a recurrent neural network. For example, if you take, for example, the input which is coming in, this input is basically nothing but a f is a u of xt plus u of xt plus 1, and this is basically the formula which is there plus software. When we apply software, we'll be able to classify whose signature it is or what type of text it is, and that is the work of the recurrent neural network which is there. The recurrent neural network takes the input at particular point of time, and then the hidden layers which are there are basically going to store, and then basically the output is given. Why storage is necessary? Storage is necessary because if there is stored, then we can understand the context. For example, the bird sat on the tree. When we are identifying the tree, we just identify it with respect to the bird which is sitting on the particular tree. The tree cannot be analyzed by itself, and that's why we need to have the recurrent neural network. We need to go back and forth. Now let us identify the what are the elements which are there in the recurrent neural network. In the recurrent neural network, there is a U. You can see we have depicted all of this in the form of tensor. Tensors are nothing but the matrices which are there, and U is basically nothing but the input which is there, and W is the weight which is we are getting, and then we have applied the tran h function with respect to the particular network, and as you can see out here, the final output which is coming ht is nothing but a function of u of xt plus w of t plus w of t, and so on and so forth. We can identify it and we can represent it in the form of tensor. We are also applying the softmax layer, and softmax layer is applied such that we are able to fully go ahead and identify which image or which text it is. For example, 0.61 probability is higher than 0.39, and at the time we can very easily say that it belongs to the 0.61 that the softmax has basically given out, and so we can say that the particular text belongs to the 0.61 probability of in which it has basically got. Now you can see that here we got a different probability, and different probability which is having the highest is basically the type of text that it is going to classify. Let us take, for example, some of the sentences. The clouds are in the dash. Like we can very easily say that the clouds are in the sky. And I grew up in France, in a small town. I speak fluent French. So these are some of the connections which are there, and this network will help to connect this particular sentences and give us the result. For example, the clouds are in the dash, where if you give this particular network, then it is very easily the answer for this dash is basically nothing but the sky which is there. And you can very easily say that we are training nothing but a recurrent neural network, and although it is difficult, but we can still train the RNNs which are there. And there is a problem. There is a problem of the gradient. Now when we are saying gradient, we are saying nothing but there is a problem of the slope, and the slope is basically going to be finished slowly and then basically going to do. Now let us see another type of network which is known as the long and short term memory, LSTM. And in this particular one, we have the memory which remembers the previous words which are there in the particular sentence. For example, let me go to the sentence once again. When I say, for example, the bird sat on the tree, if I am analyzing the tree, for example, it is the bird which sat on the tree. And for that, LSTMs are typically used, in which we use the gateways. Basically, these gates are basically going to have a cell state in which they are going to store what is the previous word. And when we are storing the previous word, we can easily take the new word that we have got, and then we can analyze it with respect to the hidden state that we have. That is, on the tree the bird sat. The bird actually sat on the tree. So when we are identifying, or when you are doing a particular analysis of the tree, it's the bird which sat on the tree. And so LSTM, long short term memories, are basically very important. Now, those of you who are from the background of electronics and computers, you must have studied about gates, and we use gates out here so that we can basically store the previous words which are out there. And LSTM basically uses the gates so that it can store the previous word which is there. Like, for example, when it stores, it's basically going to go ahead and help us to realize the context. For example, if we are analyzing the tree, we can very easily say that the bird basically sat on the tree. So the bird is important, and hence LSTMs are very important to go ahead and analyze the particular example of the tree. Now, let us talk about some of the switches which are there. For example, we are showing on the left hand side, we are showing your open switch, in which, for example, you can easily say that the output is something which we do not expect. But in the case of a closed switch, the output that we are expecting is basically a single digit one is what we are expecting, since the switch is very much closed. Now, if we are taking a open switch, we can analyze it through the output that we are getting, and also the closed switch, that we are getting output of a single binary digit. When we are taking a soft switch, we do not get a particular output of 0 or 1. We get an output which is in terms of probability. And if we are having a higher probability, we are saying that that is our result. And if we are getting a lower probability, you are saying that that is not our result. As you can see out here, that 0.99 is higher probability, and that's why we can easily use this particular switch and we can get our result. Now, this is a switch which is learnable. The operating point of it can be learned with respect to the input. So we have to train the switch, and we have to get the output, and we have to teach the machine also how the outputs can be got. Now, I just want to show you some of the LSTM long and short term cells which are there, and you can see it is very much sigmoidal in nature. And then when we are applying the input and giving some of the weights, it is very necessary that because of the sigmoidal nature, this particular LSTM is going to function. Now, these are the graphic units, and as you can see, this is the math behind that. The weight of this is into the particular previous state of the input that's given is equal to z, that is the output at the time T, and then when you are saying that you are going to go ahead and apply the tenants function, then you can very well say that you have applied the tenants function to the basically the input, and then you have got the result. Now, when we are taking and showing the comparison of the recurrent neural network where of the long short term memory, we can very easily say that the recurrent neural network is not having any memory, and that's why it cannot store the previous state, whereas the long short term memory is having a particular memory, and that's why it is going ahead and storing the previous state, and this we use to analyze the particular sentences which are there. For example, I'll go back to my old sentence which are taken. The bird sat on the tree. The tree is basically to be analyzed with respect to the bird which is sitting out there, and LSTM is basically going to help us, so that it basically, when we are telling about a particular tree, it is basically going to go ahead and say that the birds sat on the particular tree. Now, uh, when we are saying about the different type of gates which are there, we can very easily say that we have applied the tenants function, and the tenants function can be applied to the recurrent neural network, as well as it can be applied to the long short-term memory. And when we apply a particular function to the long short-term memory, it is basically going to have a particular output which is with respect to the particular function, and also taking into account the memory which is with there and which is stored with itself. Now, there are different type of recurrent neural networks. They are one to one, and one to many, and many to one, and so on and so forth. Many to many, and many to many, with the particular connections in between them. These are some of the recurrent neural networks which are there. As you can see out here, one to one is the vanilla one, whereas one to many are basically helping in identification of the images which are basically in sequence. And when we say a particular word, that we are identifying many to one relationship, we can identify a sentiment with that. And when we are having a many to many, we can classify a video, or we can classify the video on a frame level when we are having a many to many network that's there. Now, when we are doing the sentiment classification of a particular sentiment that is there, we are basically going to go ahead and go back and forth, and that is why we are going to have something which is known as the recurrent neural network, and we are going to identify what is the sentiment behind that. The movie was very boring. The sentiment out here is boring, and that is what we can do using the recurrent neural network. It can be easily identified. Now, when we are sort of identifying some of the letters which are there, like for example, ACHIN is one of the letters which are there, and when we have to identify that, then you just have to add a M in the beginning, and then it becomes a machine. And that is basically, with the help of the recurrent neural network, you will be able to find what is the sentence which should come before that, so that it will basically help us to identify the complete word which is there in the sentence. For example, let us take these particular input characters which are there. And when we are taking, for example, when the what are the input characters, and then we identify what are the hidden layers, and then we identify what are the letters that are as the output, so we can easily say what is the letter that is going to come as the next letter, and what is the letter which is going to come as the previous letter for that. So the using the recurrent neural network will be basically helping, and will be able to recognize the complete word which is there. Now when we are sort of having the recurrent neural network, it will be basically very easy to identify the words that occur plus the sentences. For example, if the sentences are spoken by one of the centers and the second person, then it is very easy to go ahead and identify what the uh, sentiment of that particular sentences spoken by two people are, and this is basically done with the help of the recurrent neural network. It's also basically very easy to identify the lemmas, which are nothing but the sentences which are in mathematical form, and this is all done using the help of the recurrent neural network. Let us take out here some of the sentences which have been spoken, and it is basically up to us to go ahead and test the particular machine. And once the machine has been trained, then we can go ahead and analyze the sentences also. Like translation, i I said that we can go ahead and do the translation, and this translation, when it is done, you can see that welcome to the lecture becomes uh, Bienvenue a la conference. In this is basically translated in terms of Spanish, and this is all done using the recurrent neural network. For example, if I am taking a particular sentence, it is very easy for us to go ahead and identify the particular sentence. For example, if the sentence where bird is flying over the lake, it is very easy for us to go ahead and use CNN and then identify the network. Plus, it's very easy for us to use CNN and RNN, and we can identify the complete sentence. Let us design some of the recurrent neural networks, and when we are using this RNNs, we can easily go ahead and identify the particular sentence which is there. Plus, we can also do the translation of the particular sentence which is being done. And as you can see, this is basically the architecture in which we have the one of the inputs, and we use CNN, which is basically the convolution, and we are using the polling. Last time we did speak about the polling, and in max polling, for example, if a particular matrix is there, then we take the highest value or the max value. Then we do some of the flooding of the particular words which are there, and we use the fully connected network, and we also use the memories which are long short-term memories, and finally we derive the output. This was basically suggested in 2017 by Rajesh and his team. Now these are some of the case studies that are there, and as you can see out here that we train the particular model and we use word to vec. to basically train the particular model. And then when we use the word to vec, basically it's going to help to transform the word into a vector notation and give us the next text, which is basically there in the particular sentence. For example, there are sentences which can be trained. For example, Mary had a wool of Shelley is something which we can help the network to train using the word to vec, and then it basically gives us the particular result. Now, this is a particular architecture which is there, in which, if we see from the bottom, then we are using different words and we are using long short-term memory. Why we are using long short-term memory is because it will remember the previous word also, and then we are doing a pooling, and that is known as the average pooling, in which we take the average of the particular numbers of the matrix, and we do a classification of the softmax, and whichever probability has high, we can easily predict that this is basically the word which was there in the particular sentence. So this is basically about RNN, which is there. I'll quickly go over one more of the slide that I have taken for you, and this does talk about RNN, so we'll be fast, we'll be going through, and this is basically a recap of what really we have learned. Now, as I told you that we are going to analyze back and forth the words which are there, and if you have to identify the particular word which is there, then it is very necessary to go back and forth. For example, if you had to identify to be or not to be, then we have to go back and forth and we have to identify the words which are going to come at a later point of time. And this is done using one such concept which is known as the graph. For example, if we create a graph like this, it is very easy for you to say that like H is there. So the next sentence which will come is nothing but the sentence Y, and Y is there. If Y is there, it is very easy for us to say that the previous word for it was nothing but H. Now, these are some of the graphs which are there, which I am showing you. And if you say, for example, the folded structure, it is very easy for us to say that the folded structure for this looks like that, looks Y of t, L, X of t, Y of t, H, and then H is going in loop, and X of t is basically the input. But when you unfold it, the X of t becomes the input, becomes a little unfolding has been done, and X of 0, X of 1, X of 2 basically comes in, and so on and so forth. We can draw the graphs for this particular architecture which is there. These are some of the common design patterns. We can either have one as a standard output, and then we can also have a recurring one in which we recur across. We have different outputs, and also we could have a particular output which is being computed at one end. These are some of the common design patterns which are basically happening. And when we are training, we can train it in such a way so that this basically goes ahead and does the computation for us and gives us the particular result. So basically, first we have to do the training, and then when we are really going ahead and executing, first we test, and then basically we need to get the outputs per se. We can also have something like a recursion out here in this networks, in which basically we go ahead and try to have the output occurring more than once, and that is known as the recursive neural networks. We can also have more than one layer as the hidden layer, and when we say we have more than one layer at the time, we can have the deep recurrent neural networks. The recurrent neural networks, which we have discussed ahead, also could be of different type: one to one, one to many, or many to one, and so on and so forth. These are some of the recurrent neural networks that can be there. The effectiveness of the recurrent neural network, it basically comes when we are training the network so that we are able to train it on a group of sentences, and then when we are training it on a group of sentences, it is very easy to predict the output that is going to come on the trained network which is there. Now, one of the problems that we face is basically the problem of the vanishing slope which is there. And as you can see out here, h of t is nothing but a q of t, wherein q specifies the quality of the output, and we are taking the transpose of that, and this is multiplied by q of h of 0, which is multiplied by q of the output which is there of the particular input that we are giving. And when we are using the power method, at the time it is very easy to go ahead and identify the output weight which is there, and it is a input weight multiplied by the transpose of the input weight which is basically coming in. When we are doing a backward, we are basically doing nothing but it is basically of the linear structure that we are doing, because we have gone through that particular input which is there at some earlier point of time. Now, I mentioned to you that there could be a loss in the level of the RNN, recurrent neural network, and that's why we use long short-term memory which is there. Now, you can see, for example, these are some of the Python codes which are basically written, and when we are doing the backward pass, it is very easy that we basically go ahead and have a particular gradient or slope, and we also go ahead and diminish it at some point of time. Now, how we are going to overcome the gradient or the slope issue? The gradient or the slope issue is basically overcome by the help of using different functions. And as I told you earlier, that we are using tanh, but in this case we are going to use ReLU. Is rectified linear unit is something which we are going to use, and the ReLU graph is something which I have discussed earlier. It is basically going to have a 0, and then suddenly when it finds a number that is basically coming in, it is going to have the particular number that is from the graph. We can infer that till 0 it's basically going to be 0, and then when it finds a positive number at the time, it's going to have the positive. For example, if it is 1, then we are going to have 1 as the output, and then we can easily say that it is following the ReLU. And these are some of the strategies which are there, and you can see one of the strategies is regularization, and then we maintain the information flow which is there. We have different type of networks which are known as the eco-state network, and these networks are basically used to identify the particular like outputs which should be there when we are initializing the particular weight of the particular recurrent neural network. These are some of the LSTMs which are there, and when we are saying that LSTMs which are there, these are basically going to have some of the memories, and these memories are basically going to help us to analyze the past, and then when the past is analyzed, these are basically going to maintain the context, and basically we can then identify their the present one is with respect to the past which was there. For example, if you are having the particular sentence of the bird sat on the tree, when we are identifying the tree, then it is being the bird which is sitting out there. These are some of the functions that are applied, and as you can see out here, we have applied nothing but the tanh function out here. Now, these are some of the LSTMs, and these are you can see out here in the LSTM, we are going to have a memory component also, and we are having the memory component. It is very easy to go ahead and analyze, whereas in the recurrent neural network, that is the RNN, we do not have any memory structure, and so it is very difficult for us to go ahead and analyze this particular RNN. Whereas if you use LSTM, then it has a memory component, and this memory component can help us to identify the previous words which are occurring. This is the LSTM, and as you can see out here, that these are some of the equations which are there for LSTM, and you can see that when we are going to go ahead and forget about the previous context, then this is the equation f of t is equal to sigma of w t h of t minus 1 x of t and then b1. But when we are taking the previous component we are there, then we have to also take the previous component and we have to multiply it by the value of ct, that is the previous component which we are having. And finally, when we want the output, we are basically going to pass it through one of the functions, and this function could be tanh or could be relu, so on and so forth. We could identify the LSTM network. Now, when we are saying we are having gated network, then we apply a particular gate, and this gate could be anything, and then the particular structure of the output depends on the gate that we have applied. Now it is very easy for us to go ahead and have LSTM instead of RNN, and this particular Space Odyssey, when we are searching this particular book, he has done this particular paper, and he has trained in the book that he has trained for 52,000 iterations, and he has used 15 CPU years for going ahead and doing the training, and then he is able to identify that particular book. Now we also have some of the networks which are basically sequence to sequence network. They are going to identify that a particular sentence which they are going to identify is basically from the sequence, one sequence to the other sequence, and then we are, if we are having an email coming like are you free tomorrow, then the decoder is going to really go ahead and have the sequence identification yes, or it is going to have the sequence identification of a no, for example. These are some of the sequence to sequence, and these are some of the different networks in which we have identified, and we are basically going to go ahead and give this particular result. in which case a sequence to sequence identification has been done. We can use also the memory for this purpose, and as you can see that explicit memory can be used for this purpose. We also use some of the other different type of memory, and some of the different type of memories can be used, and these are some of the people who like western graves and so on, who have used this particular memory, and then they have identified the network, and these networks can easily be used. When we are using soft addressing, we can easily say that they are content based, or we can easily say that these are location based when we are using the hard addressing. These are some of the networks that we are using, and we are using some of the memories. Like, for example, if we have to store the previous state of a particular sentence, then we are using the memory cells for this purpose. These are some of the resources and references, and uh, I'll quickly go over to the next slide deck, which is the deployment of the ML solutions. And if you have any question, you can ask me at the last 5 or 10 minutes. You can ask me. Now, this is about the machine learning process that we are learning. And when we are basically going for the machine learning with the big data we need to provide to the machine, we need to have something known as the data cleansing, the data integration, and subsequently the rejection of the data. These are different steps, and then we go ahead and create the model for that, and subsequently the model is what we deploy and get our results. Now, for example, it's very uh, necessary for us to understand the business process and what is the return of investment that he's going to do, and then he is going to analyze each of the buckets that is there for the problem, and then he's going to have the data for each of the particular identification. Now, what is the engineering behind it? The engineering behind it is basically tinkering or going ahead with exploring the particular data, and then he is going to build a particular model for each of the different types of things that he is finding, whether that be a sentence or whether that be an image. So before he does the deployment of it in production, he is going to have the validation done, and then he is going to divide the data into train, test, and the validation part of it. And this is basically done in the different industries at different ratios. For example, train, test, and validation is basically done in the ratio of 70, 20, 10. For example, we could take any of the ratio, and we can basically do the division, and that is basically up to the data scientist. And we can also plot the error metric and then pick the model wherein we are having the highest degree of accuracy. Now, when we are doing a classification, it is very important for us to go ahead and analyze what are the training timings which are there, and what are the test times which are there, and the accuracy and interpretability and the classification decision boundary, and what is the ramp which is taken at their particular test time. For example, we have to also gain the acceptance of the particular people who are there, and we have to ensure that we are basically maintaining the highest degree of accuracy. So if you are thinking about which particular model to go ahead and deploy, then it is very necessary that you establish a model which is having the highest degree of accuracy, and subsequently you deploy that particular model. What are the practical issues which are there in machine learning model? The practical issues is basically about the different algorithms which are there, and it is very much that overfitting could take place. And what it means by overfitting is that for a particular data, the learning which the machine does is basically going to follow that particular curve, and that is known as the overfitting curve, when it closely follows the particular data which the learning is supposed to take place. It may also be cost sensitive, or we can select some of the good predictors as features, and then we can go ahead and analyze. This is all that I had. Hope I am on time. And if you have any questions, please do ask me. Please unmute yourself and ask me whatever questions you have, and subsequently I'll go ahead and uh, pass the control to you
Rajesh
so
sir,
that you can present it. Yes, sir.
this is Patanjali.
Yes, sir.
Sir,
Good morning, sir.
yeah, Rajesh sir, this is Patanjali. Uh,
Yes,
sir,
sir. Yes, sir.
actually, thanks for accepting our. Yeah, yeah. Before they post any questions, I've seen few queries actually in the chat box, and this proceeds for the
Yes, sir.
like our post you the questions. I would like to just thank you because actually you have accepted our invitation and then you have taken continuous 5 week session, maybe 4 week session, where you are involving students and faculty members, and our faculty members also getting trained
Yes, sir.
along with the students, and also
Yes, sir.
many students are like I feel that the participation is very good and very nice. Nearly 79 students have participated. Um
Nice.
and the thing is,
Yes, sir.
like definitely the students would have they should get benefited out of sessions. That is our intention. And I thank you, sir, for accepting, because I have pinged into your session, but I could not speak with you because due to my administrative activities, I could not talk to you. Mostly, I would have I contacted you offline many times, but in this session, I want to come today intentionally. Why? Because I want to see what is the participation and how I want to hear from the students also, how they got benefited and anything. I want to tell all the students one thing. Actually, Rajesh Kumar is a senior architect from Infosys, and every Saturday you have seen him. He has not missed any session. You be on time, and then he's taking all the sessions, and he's very much interested in speaking with the students, not only in the sessions like this. He also, if at all you have any queries, you can directly speak to him, and but you have to take appointment well before you you want to discuss anything with him, and he's occupied with his official work. And quite in the midst of this, I feel like I'm very happy, and then I want to share my happiness that like whatever with what intention I have connected along with Absar sir and Tarachandra sir, and both of them have done they are actively involved, and then they are arranging all these sessions for you people. And I want to see that students should benefit, and they have to come out with projects which will help them during what you call their campus recruitment and all those things. So if you do good projects in machine learning and sometimes in deep learning also, you getting job is not that much difficult for you people. but understanding the concept and implementing all whatever you have learned all these 4 weeks. I want all the mentors, faculty mentors, to work along with the students and bring and also Rajesh Verma garu is very active in LinkedIn. I want all of you to connect through LinkedIn, and whatever you want, you can ask questions and anything related to artificial intelligence, IoT, right? And also
Yeah.
he's good in R programming, Python programming, and
Yes.
cloud computing, right? Business intelligence, because he's a very senior associate. He worked in TCS, as of I know, like he was our ex-colleague in TCS. He worked in TCS, he worked in Infosys. So with all his rich experience, he's sharing his what do you call the content, whatever content you need. Freely he will share with you people, so that you have to understand, and getting such people is very difficult from industry. And we are fortunate to have Kumar Verma, Rajesh Verma garu, because he's one of our GB members also, general body members also. So being in that, he wants to do some service to our institution. So this way he is connecting with all the students, and I'm very happy today connecting. And then thanks for giving me this opportunity, Rajesh Kumar Verma garu. For few minutes I could share my happiness. So for that reason, and I want to listen from the students queries, as well as how the session has been benefited you. So I want to listen from you. Thank you,
Thank
sir.
you,
Thank you
sir.
very much, Rajesh Kumar Verma.
సార్ గుడ్ మార్నింగ్ సార్. శాస్త్రి సార్ గుడ్ మార్నింగ్ సార్. నేను సుధాకర్ సార్.
Good morning. Good morning. Yes. Good morning, sir.
సార్, విత్ యువర్ పర్మిషన్ and also Rajesh sir permission, can I present the vote of thanks also, sir?
No, before that,
We start student presentations here.
Okay, sir. After that, I'll present, sir.
After that, you can propose a vote of thanks, and before that, Rajesh Kumar sir also will speak.
Okay, sir.
Right? It will go like that. Thank you, sir.
Okay, sir. Sir, thank you, sir.
Thank you very much, Patanjal sir, and my thanks to Sudhakar sir, Sarath sir, and Durga madam, and all the sirs and madam. Also, my thanks goes to them, and the students also. Thanks for attending all the sessions religiously, and I just want to say that learn AI/ML very well, and deep learning also very well.
Sir,
And
excuse me,
this
sir.
is always not a problem for you. You
Sir,
can very
Rajesh,
well
sir.
do your own projects. And
Sir,
now,
Rajesh, sir.
yes, Sudhakar sir.
Sir, please press stop presenting, sir, so that we can see your picture also, and we want to take a screenshot of it.
Yes, sir. I have stopped sharing, sir.
Yeah, thank you, sir. If you don't mind, would you like to turn on your video, sir? We want to take a picture.
Okay, sir. Sir, are you able to see now?
Yes, sir. Little bit, sir. Yes. Yes. Thank you, madam. Thank you, sir. I would like to take a picture, all of us. Okay, sir. Thank you, sir. No problem, sir. You may turn
Thank
off
you,
your.
sir. Thank you, Patanjal sir. Nice
Please carry.
talking to you, sir. My previous colleague in
Rajesh
TCS.
garu, I could see you. I could see you now.
Yes,
How
sir.
are you?
Fine, sir. Although I am not well,
Yeah.
but
Ah,
I really want that all the students should benefit, and they can go ahead and do AI/ML projects and deep learning projects for the different departments which are there in the city, as well as they could come outside and then go ahead and do the
yeah.
projects in this particular space. And there is a huge demand. I just want to say there is huge demand everywhere globally, and job is not a problem. And my request to all the students is that They basically learn AI and machine learning and deep learning very well. And once they are thorough with this particular knowledge, it is very easy to get a job or to do further studies. And thanks to Patanjali sir and his team of faculties who have arranged this particular lecture. Now we'll go to the presentation of the students for the next hour or so.
Madam, good morning,
Rajesh,
madam. Sajana, madam.
sir.
Uh,
Can I
Banu
call
Priya.
Bhanupriya?
Yeah, yeah, okay, okay.
Okay, sir.
You can call Banu Priya. Okay.
Just 1 minute,
Bhanupriya,
ma'am.
are you ready? Okay, okay. Carry on.
Yes, ma'am. Just 1 minute.
Like if you can start the presentation now, and towards the end we can have as many questions as you want from this particular space of AI or machine learning as you want. Now, Brown Priya is starting the presentation. Thank you very much.
Bhanu,
Ma'am, it's some disturbance, ma'am.
what now?
Ma'am, it's okay?
We are not seeing your presentation. Okay, okay, Bhanu.
Ma'am, it's
Sir,
okay, ma'am.
okay, it is visible to me. Sir, Rajesh Verma, sir, is it visible, sir?
Yeah, we can see your presentation.
Okay, sir.
Banu,
Bhanu, you
please
start
go
your
ahead.
presentation with your introduction.
Okay. Sir, it is audible, sir. My voice.
Audible,
Yeah,
Bhanu?
yeah, yeah, very
Okay.
much.
Banu
We
Priya, you
can
can
see
start.
your presentation and we can see
Okay, sir.
your, we can hear you also. Please start.
Okay, sir. Good morning, sir, and myself, Bhanupriya from 3rd CRCB. Today, my presentation on convolution of a neutral network.
Banu
Uh,
Priya, can you make slide, full screen? Make slide full screen.
And you press F5.
okay, ma'am.
F5.
Press F5.
F5. Go into presentation now.
Oh,
Ma'am, now it's okay, ma'am.
Just wait a second. Yeah, it is loading. Uh, so, okay, continue చేయనివ్వండి సార్. Bhanu, you go on.
Ma'am, it's some problem. Wi-Fi
Okay, okay,
disturb.
okay. Okay, Nana, you go on.
Okay, ma'am. And now, convolution neutral network, computer visualization and ma'am, it's disturbance.
You are getting some disturbance, Nana.
In my side, ma'am. Can I start, sir?
Please go ahead.
Okay, sir. Okay, sir. Sorry for waiting, sir. And mainly, CNN is a computer visualization, and it is a day by day it will be improved, and it is mainly reason to develop the uh, deep learning. And when we talk about the computer learning, we can be CNN is our brain as an example, and like it will be picture imagination and picture classification, and I am explaining about the what is the CNAs. It is what it all it, it is a matrix. It is a matrix multiplications in the one layer to another layer. It is a 2D dimensional, not it is a 3D dimensional. It will be mode of the convertancy. RNN is an useful to 3D conversion. And why should we need to CNN? Why should you need to CNN is the networking and fully connecting on networking in the neutral from the for given the output, and it will be used the image representation. Main it will be first of all we seeing any picture in black and white. It will be converting the RGB colors. Then we visualize the what you are now seeing like. Then black and white picture is 28 into 28 into 1 is a black and white picture. Is a black and white picture. Then we using a RGB. We will converting into the 224 into 224 into 3 ratio picture, and the few will be the few features will be added in this page, like image representation. And first of all, image representation. The image representation is like that. Sir, are you audible?
Yeah, I can
It's
hear you.
audible.
Please
Audible,
continue.
ma'am.
And it will be in this picture we can see the RGB model, RGB, and it is the some length and breadth. In any picture we are seeing in before in outside this these three colors are be present. And next one is edges detector. Edges detector is mainly every picture has be a horizontal and vertical edges, and dimension of tree into tree. It will be like this picture, the first picture like this picture. It is a picture, this not a outskirts. The edges will be some like what all like it is not uh, some the edges is like what some edges is extra too covered and the picture is clearly visible, then use it this method. and and the layers, these are layers of the CNN. The first layer, the input when we are taking any picture is an input. And the congo layer, the congo layer is the extra feature of this layer. And this layer is used to mainly this layer is used to the first part of this layer, like example, this is the part we taken. This part is the some different layers. In this part we can in the picture this part will be there. It will zoom and it will be clear to another layer. and also that one place we using all the layers when clearized picture is there, is visible. And the next one is fully visible fully visible layer. Fully visible layer is used to, and in this between the fully visible layer, like these are the fully visible layer. The fully connected layer is used to like what you picture to see, that will be clearly visible like that. And softmask layer is an converting the small bits, any not clearance that will be clear on that. The output layer is visible to output. And these are the
I know, just a minute. Can you go to a previous slide?
like this side, sir.
No, the previous one to that. These are the the different layers of the CNN.
Yes, sir.
Next, please.
Thus, this layer is used to develop the original picture, sir.
Yeah. Next, please.
Next will be coded, sir.
Next slide. Next, previous slide, please.
This side, sir.
Layers in CNN. Layers in CNN.
Yeah. I just want to say that you are correct, absolutely correct. These are the different layers of the and those who are not seeing, can you please go on mute? These are the convolution layers, and this is the activation function, which is ReLU, and ReLU stands for the rectified linear unit, in which you have correctly drawn the graph, Banu. And then we are having the layer which is known as the max pulling layer, which is basically max pulling is one of those. And then we are going to divide the particular matrix, and we are going to take the maximum value, and then this is the fully connected layer, which is basically going to take the particular image and do the flattening, and softmax is going to do the classification. So you've correctly done it, Banu. Please proceed with the Keras code.
Carry on, Bhanu.
Yes, sir. Yes, sir. Yes, ma'am. Next slide is it is an open software. It is a open source. We developing these any coding like building the picture like coding form. This will be coded, sir.
Okay, now please show your collab, what you have done.
Sir.
Yeah. You please speak about this, whatever slides you have, and then please show your code.
This will be code, sir.
Okay. You are not running Google Collab. In Google Collab. Banu, you have not done in Google Collab?
I have, sir, 1 minute. Sir.
Those who are not speaking, please go on mute. Second point is collab. Banu, please show.
Hello, Bhanupriya, are you there? Hello, hello, Bhanupriya. Hello, madam, Sajanya madam.
Yes, sir. Cheppandi, sir.
Bhanupriya, did you did you did you execute this program in Google Colab?
Sir,
Hello,
sir, అది నేను
Bhanu.
execute చేశాను.
Okay, sorry is asking about open your Google Colab and see the code and output. Just open your browser
Sir,
and open your Google Colab and hello. Tell me,
sir, నా
Bhanupriya, tell me.
సార్ నా ల్యాప్టాప్ ప్రాబ్లం వల్ల అది కోడ్ ఎగ్జిక్యూట్ అవ్వలేదు సార్. నా ఫ్రెండ్ దగ్గర కోడ్ ఎగ్జిక్యూట్ అయ్యింది. సో ఐఎమ్ సేవ్ ద కోడ్ ఓన్లీ.
Okay. So let me explain the code once again for this PPT only. Okay,
Sir, can I explain the
let
code,
me
sir?
explain the code. Okay, carry on. Carry on. Please unmute yourself.
Sir, these are layers to use to developing, sir. For I am going to I am taking to move the one train, sir. Like one any motion to move the one place to another place, sir. And I am taking the x and y is an operations. Then testing cases. These are to loaded this type from these are two motions. These are one the x and x object and x object on the train, x object on the trace. They will be equal to the x trains. Then it moves the one place to another place. I am given here. I am given from the matrix also, sir. This matrix, this and this matrix, sir. And model and I'm taking this object ft, sorry, tf. I'm using the software from the kernel, sir, to develop the using of layers to implement this, sir.
Yes,
Okay, control. Okay, you can
Sir,
go ahead, Bhanu.
the
Go ahead.
please continue. Banu, I am interested in seeing your code and also Google Colab. Please continue.
sir, here's some disturbance, sir. So I'm sending the code from the Google Classroom, sir. In my house, some disturbance, sir. Sorry for saying this, sir.
Okay. Sure. We understood that your code that you are writing, and when you are saying import TensorFlow, TensorFlow is a deep learning library from Google, and you are saying import TensorFlow as TF, and that is what you are using in your program. So we understand that. Now, since there is some disturbance at your home, you are not able to execute that code in Google Colab. That's fine, Bano. Thank you very much and good work. And I request the next participant to please continue.
Please Please, mentors, anybody else there from your side give presentations? You are what students? I think last week some few students are unable to give presentation. Those who are there will give presentation right now. Hello, mentors, please respond.
Tessely, are you ready now?
Okay, yes, ma'am.
Yes, ma'am. Ready?
Okay, start.
Okay, sir.
Where is your desktop screen? Share your presentation,
Okay, sir.
Tisani.
Okay.
Okay, okay, let us start. Highlight it. Tisani, share your desktop and start your presentation right now. Mentors, please help to Tisani.
Sir, is my screen visible?
No. Yeah. Continue. Go ahead.
Good morning, all. Myself, I'm Tesni from CSCB. I want to explain clustering. Um, it is a task of dividing the population or data points into number of groups. It is basically a collection of objects on the basis of similarity and dissimilarity between them. Actually, clustering have the similarity and dissimilarity when it forms. For example, the data points in the graph below clustered can be classified into one single group. We can distinguish the clusters and we can identify the three clusters in the below picture. Here is the picture. We seen here three clusters, and three clusters are in circular shape in picture. But actually, the cluster is not in particular shape. It's either be a triangle or rectangle, whatever shape it is, but it is not in a particular shape. Why we using clustering is very much important as it determines the intrinsic grouping among the unlabeled data present. There is no criteria for a good clustering. It depends on the user. This algorithm must make among assumptions which constitute the similarity of points, and each assumption make different and equally valid clusters. It depends on the user what is the criteria they may use which satisfy their need. For instance, we could be interested in finding representatives for homogeneous groups, in finding natural clusters and describe their unknown properties, in finding usable and suitable groupings, or in finding unusual data objects. We have clustering algorithms. One of them it is K-means clustering algorithm. It is simplest unsupervised learning algorithm that solves clustering problem K-means. K-means algorithm partition observations into K clusters, where each observation belongs to the cluster with the nearest mean serving as a prototype of the cluster. Cluster we can use cluster in so many fields. Those are marketing, biology, laboratories, and libraries. Here is the picture, K-means clustering, how we uh, represented in graphically. And one of the algorithm is k-nearest neighbors. K-nearest neighbors is one of the cluster algorithm in machine learning. Belongs to supervised learning domain and finds intense application in pattern recognition, data mining, and instruct detection. Here is the picture. Here is the picture that represents it detects the pattern of the cluster. We have so many types of clusters. Those are partition clustering, hierarchical clustering, density based clustering, distribution model based clustering, fuzzy clustering. Partition clustering is a type of clustering technique that divides the dataset into set number of groups. It can also called as set based methods. Hierarchical clustering means it is also one type of clustering technique, and it also divide the data set into number of clusters where the user does not specify the number of clusters to be generated before training the model. This type of clustering is known as connectivity based methods. Density based clustering means in this clustering technique, clusters will be formed by segregation of various density regions based on different densities in the data plot. Density based spatial clustering and application with noise is the most used algorithm in this type of technique. Distribution model based clustering means in this type of clustering technique, clusters are formed by identifying by the probability of all data points in clustering come from the same distribution. The most popular algorithm in this type of clustering is expectation maximization clustering using Gaussian mixture models. Fuzzy clustering means belongs to a branch of soft method. We have seen all above 5 4 methods. 5 4 types of clusters are hard method clusters. In this fuzzy clustering degree then points at the edge of the same cluster. The probability of a point belonging to a given cluster is a value that lies between 0 and 1. I am giving conclusion. There are some of the different clustering techniques that are currently in use, and in this article we have covered one popular algorithm. In each clustering, we have to choose the type of technology we use based on our dataset and the requirements we need to fulfill. Thank you.
Thank you very much. And now, could you please show your code of assignment 2 and assignment 3 also if you have done, but at least for the assignment 2 of clustering, how you did it?
Sir, actually I did not complete, sir. Um, I want to complete. I
Okay. Okay.
Okay.
Thank you very much. And next one, please. Yeah, please start your presentation. The next participant.
So actually, the next participant Chaya is not presenting today, sir, because her mother health is not good. She is in hospital. I think no one is there, sir.
And if anyone is not there, Can I proceed for the final note of?
So before that,
Sir,
we have to conclude from our side, our mentor side, and then
Okay.
you follow the
Sure, madam.
session.
Sure, madam. No problem.
sir, Durga madam is there. Madam has some questions from your students side, sir. She is asking some questions to Rajesh Verma. Madam, please respond me, madam.
Good, good,
Okay.
good. Thank you, madam.
Please go ahead with the
Please go ahead.
Madam, Durga madam, let us start right now.
Okay, okay. Sir, multiple levels of inference means sir.
Durga madam. Can you please repeat?
Will you please repeat, madam, once again? Madam has just left, sir. I think he is a network. He is in network problem. Madam, please repeat the
Sir,
question
here
once
also
again, madam.
having a question. Sir, can you please explain that GRUs, gated recurrent units?
Yeah, like what we are trying to use is basically the recurrent neural network. Uh, then, in the case of recurrent neural network, that's a deep learning network. And in this deep learning network, we are either trying to understand the language which is written, or we are trying to go ahead and understand the signature which is there. And using the recurrent neural network, when we establish this particular RNN with the gates which are there, then we can basically store the information which is previously existing, or what we do is we basically have the particular gates store the information which is basically occurred in the past, and then we train the network. When in this case, when we train the network, we will very easily be able to identify a particular text which has occurred in the past, or a signature type which has occurred in the past, and using this particular RNN, which is basically to identify the sentence which has occurred in the past, or a word which has occurred in the past, or a pattern which has occurred in the past, it will be able to give us that this particular text is having something which has occurred in the past. For example, the bird sat on the tree, then it will be able to point us to the word bird, which is basically sitting on the tree, or if there is a signature, then it will be able to point us to the signature, the variety which has occurred in the past, and it will be able to identify the complete signature or the complete sentence which has occurred. And this we do it through the use of gates. And when we do it through the use of gates, we use the signal which is coming, and then the signal is going to either go ahead and have a particular signature stored, and it is very easy to go ahead and uh, tell the particular text or the particular gate which has been activated, and that's how the RNN or the recurrent neural network works. Basically, we have to say that CNN is used for the images, and RNN is used for the text which has been there. Thank you very much, Durga Madam.
Okay, sir. Thank you, sir.
Any other questions that you have?
Yeah, sir. In chat box, we had one question. What do multiple levels of inference means? Is it advantageous to have multiple levels of inference?
Yes, when we are having multiple levels, then take the example of a image. Then one of the levels will go ahead and identify. If we take the image of a cat, we'll identify the ears of a cat. For example, the ears of a cat are basically sharp. That is one level will do that. And the second level will identify the nose of a cat. The nose of a cat is generally sharp. And the third level will identify the particular mouth of a cat. And in this way, if we are having deeper number of layers, that is number of layers more than one, it is very easy to learn the features of a particular image that we are taking. And when we learn the features of a particular image, then it is basically able to identify all the cat images that we are giving to the particular network. And in this way, having more than one layer is definitely an advantage in case of CNN. In the case of RNN also, it is very easy to identify the signature of a particular person or the language that a particular text is giving out, and it is very easy if there are more layers and each layer can learn a single feature, and then this single feature and is a it gives rise to one or more features, and the particular network will learn that and will be able to identify the particular signature or the particular paragraph that has been there in the uh, text and for which the network has been trained. So it is definitely an advantage if you have more than one deep layers or hidden layers that we call in case of CNN and in case of RNN also. Thank you, madam.
Sir, one more question is there. What is the empirical risk and what is the empirical risk minimization, sir? Hello, sir.
Yes, madam.
Sir, is that one more question is there, sir? What is the empirical risk and what is the empirical risk minimization?
Okay. When we are talking the empirical risk, if we have a particular network, the risk that we have, if we are having the particular network layer, is that we are having the problem, like I showed you, that we are having the problem of the gradient or the slope, and we need to ensure that that particular risk is basically minimized. And that is when we are saying that we are having a particular slope or gradient, then we have to go ahead and minimize it. And when we are minimizing that particular risk, at that time we can say that our network is now performing very successfully and it is able to identify the particular image or the text. In this case, we have to minimize the empirical risk, and we have to go ahead and see that our network, which whether it be for image or whether it be for language, that is basically trained well. And once we are training it well, we can minimize the particular risk that is there. Then when we minimize the particular risk, then we are able to train our network for the identification of the images. So if you give the images of a cat, it will identify it as a cat only, and it will not identify it as a dog. So that is what we need to do in the case we are trying to train one of the network. In case of CNN, convolution neural network. If you are trying to identify the particular signature of a person, then we will take the RNN and we have to ensure that we minimize the signature identification of a particular person, and we are able to do it well. And that is basically the identification of the correct signature and minimization of the risk which is there in the correct identification of the image or the particular signature of a particular person.
Thank you, sir. Thank you so much.
Any other question, please, from anybody?
One more question, sir. What is overfitting?
Overfitting. Overfitting. Like this is a concept that is basically happening when we are trying to train our model. When we are trying to train our model, if our model is such that it is basically going to go ahead and basically identify each and every row which is there, and basically the model is basically catering to each and every row which is there, then it is known as overfitting. Take for example, this particular example is there of a particular person playing, and so in this case the data elements which are there, the data elements, if the model is such that we have basically for a particular case also we have uh, taken our model and we have uh, gone ahead and we have said that the result is going to be for example x true, that the person is going to play under these conditions also, then we are basically doing the overfitting of the model that is there. So in case of overfitting, we are basically going ahead and identifying the different data points, x1, x2, x3, x4, xn, and then we are having the model catered to x1, x2, x3. That means all the all the variables which are independent, and the y which is a function of x1, x2 to xn is basically going ahead and seeing that the model is catering to each of the x1, x2, x3 to xn. Then we are saying that the particular overfitting has happened, and we should avoid overfitting, and we should then go ahead and create our model successfully, so that the next training and training is done successfully, and then with the testing, you are doing the testing, it does not fall into the overfitting issue which is there, and we are able to go ahead and do our testing well. Hope that clarifies, madam.
Yes, sir.
Thank you, sir. Thank you very much. And over to Sudhakar, sir. Sir, let us ask our valuable feedback from our students, sir.
Sir, thank you, sir. Sure. Dear all students, I really appreciate your interest and enthusiasm. And I hope you have utilized this wonderful concept in all these 5 weeks. Probably few of you are missing, maybe sometimes you may miss the class, but we have kept all the videos and lectures which are recorded during the presentation of our esteemed resource person online, and I will share you that particular link also. Just a second. And I would like to share a small presentation on this particular occasion, and I would like to just convey my thanks and wishes to everyone, and I mean as a part of vote of thanks. So please bear with me for not more than 2 or 3 minutes. Okay. So I have shared the feedback link in the chat box. Please go through it. Not now. Please watch this presentation for 2 minutes. So I would like to convey my thanks. And before conveying my thanks, I would like to emphasize some of the few points on the department. So our department is now has introduced two new branches: artificial intelligence and machine learning. Second one is Internet of Things, cyber security, and blockchain technology. These two branches, each 60 seats, we have introduced in this first year. So your juniors you may see your juniors in the second year with these specializations. They only study artificial intelligence and machine learning. And also, after section, they are going to study Internet of Things, cyber security, and blockchain technology. So, in your friends or anybody else who after the intermediate, if they still want to pursue BTech and they want to get into very good engineering specializations in computer science, so you may these two branches in our campus. And in our college, we are having a revelation in incubation centers and new labs. So, under the leadership or head of the department and faculty and the esteemed faculty and research members, so we are in collaboration with industries and organizations to establish new labs in the area of AI and ML and also cyber security, IoT, blockchain. And our students, we are really happy to see our students are doing very well in internships. Please continue your success. And also from Yantra labs and other labs, each labs, our students participate in very innovative projects. And also they have gained national and international prizes. And also our students, they have achieved organizations in the earlier. I want your batch. We are all from the entire PSC department. We are wishing you all the best for winning placements in companies like Oracle, Microsoft, Google, etc. And if you want to pursue more education in the higher level by crossing the borders of our country, you are most welcome. And your seniors, more than 40 to 50 members are there in overseas from the Department of CSC. And I would like to emphasize some of the strengths of CSC department. We are having more than 3 doctorates and nine faculty members are pursuing PhDs. 5 associate professors are there. In 2 years, our department have achieved more than 130 papers, including student paper presentations and five patents. And recently, our head of the department have achieved 12 lakh funding project from the government of India and more than 5 consultancy projects. And we are going strong in academic and research. And I'm delighted to let you know that our department is associated with some of these professional bodies which are nationally and internationally renowned and recognized, who are having the highest level of technology. And now I would like to come to our workshop, which was inaugurated in November 28th. And we are now, just a second. And we are now in the last day. And I would like to emphasize on the placements. We provide 100% support. You can see now from our department, Hanuman sir, Silpa madam, and many other Durga madam, and many other faculty members, Prasad sir, Saujan madam, the core technology team are honestly and working hard behind the screens all the time to support you, empower you, and also Murali Krishna sir, under the leadership of our HOD sir, they are doing very well to ignite you and also to let you placed in more than 5 to 10 lakhs packages. I hope by the time you come to the final year, I believe that you will definitely cross more than 15 lakhs package per annum. And innovation, our department is second to none innovation and also entrepreneurship. Most of the students, they have presented their ideas and they are reaching to the final level. In your current final year students, two people, they have already made their own companies registered, and in seniors 2019-20 batch, they also founded their own company in IoT and robotics. And these are the corporate gains who are in relationship with our organization. So I can say they are millionaires and they are in tie-up with our Department of Computer Science and Engineering under the guidance and leadership of our HOD sir. And you can see some of the photos. I just took a one simple photo, so which was taken at the inauguration of our H Labs. These are the people who have visited our Deputy Chief Minister, and they have done their good job. And finally, I would like to thank you, Sir Rajesh Kumar Verma garu, So, I mean, it seems to be very simple, silent, and calm, but actually, you can see the picture on the left. He is very dynamic in mind, and also he will provide thought-provoking ideas to guide not only students. I would like to thank you, sir, for being our Board of Studies member and also guiding our faculty. So, for my knowledge, I am in communication with you since last 5 years. So after the, debate of our HOD sir, and I really thank you for your inputs and also for your valuable time and patience, especially to bear with us because we don't have a single alphabets in machine learning, but you have helped us to dig a little bit. I can say up to my ankles of depth in the levels of the water levels of the machine learning. And I believe, and also I thank you, Rajesh Garu, for designing such a good methodology and also approach to bring up the outcome of the students. So while learning in workshop series and also helping me to oversee the things that I have never done before. And thank you, sir. Thank you for your valuable inputs. You have not only guided our students in technically and also guided our mentors and also helped me and Sastri sir to oversee the administration of this technical extravaganza in the last 5 weeks. I believe our students will definitely make a mere impact in their learning outcomes of the machine learning, and also they will definitely make a good point in their life at the end of the course curriculum. I thank you for the presenters, especially our students. You have taken our inputs as challenging, and sometimes you may find nights and days to work on that. And also, you are second to none. And without your participation and interest and cooperation, and your respect and honor to the department and to the faculty, we really love you all, and we thank you for your valuable participation. And you valued our inputs, you valued our words by our mentors and the faculty members of the department. And finally, I would like to thank the esteemed members who are the mentors, Saujanya ma'am, Mahalakshmi madam, Sri Ramya Krishna ma'am, VSRK Prasad sir, and also the dynamic Sir Chandra sir, who is fabulous in the lines of quotes for all the students, and he is
Sir,
always
sir,
there
and
for
one
us.
more Durga, sir. One more Durga madam also, sir.
Ah,
Durga madam.
my apologies. I forgot to. I mistakenly. Skipped. I'm sorry. I'm sorry for this. Sorry, Durga ma'am. And Durga ma'am is also there. And thank you for everyone and for the mentors, especially their untied effort. So out of the busy schedules in the department, at home, they made their time to support and guide the students, which is a great thing. And this represents the dedication of the faculty members of the CSE department towards the students and their valuable inputs. And finally, I would like to thank everyone for giving me this opportunity to coordinate and to work with you in this extreme event. And I really love you all for participating in this. And I hope you make some time and also take time to learn more so that you will get more benefits and also you will reap the best out of the future that is going to coming into your lab. And throughout this year, I believe, and also for the next year also, and I'm wishing you all a very happy learning and also advanced happy new year. And thank you very much, and thank you very much once again.
Thank you very much, Patanjali,
Thank you, sir.
Sir, Durga Madam, and thanks to all the faculty members and to all the students also for participating in this particular AIML and deep learning workshop. And my request is simply that you complete the assignments 1, 2, and 3 that we have given you, and also go ahead and do a project in this particular space so that you get hands-on and you also understand the world and the application of AML and DL in this particular world problems. And this year is going to be ending. So happy New Year 2021 to you. and also do your AML and DL very seriously and learn it once for all. You have bright future. All the best. And thanks to Patanjali sir for giving the opportunity, and to Sudhakar sir, Durga Madam, and all of the faculty members, and all the students, and all the best to all of you. Thank you very much. Bye bye.
Thank you, sir. Thank you very much. And students, please unmute yourself and say thank to our beloved Rajesh Verma garu. Students from your side also give thank to.
If you
Thank you,
want,
sir.
you can open your
Thank
video
you, sir.
and show your
You are welcome. Please find all the material.
Thank you, sir. Thank you for sharing this machine learning land.
Thank you so much, sir, for this great session.
You are welcome. Welcome to one and all, and thank you very much. And please learn the material which has been shared in the Google Classroom, whether it be those particular lecture or whether it be assignment, and do as much as possible so that you are able to go ahead and master AI MDN, and nothing can then stop you. And the sky is the limit. You can achieve many things, and we have to do a lot of 2021. In 2021, we are going to do a lot of projects in AI and DL space, and you should basically be prepared to go ahead and master it well, and then you should be able to execute projects successfully. And all the best to one all of you. Thank you, Patanjali sir. Thank you, Sudhakar sir,
Thank you so much,
madam,
sir. Thank you.
and thanks to each and every one of the students, and wish you all a very bright future. Bye bye.
Thank you, sir.
Thank you
Thank
so
you.
much,
And
sir.
Thank you so much, Rajesh Verma sir.
thank you,
Thank you.
thank you all mentors.
Thank you, Sarat Verma garu and Sudhakar garu.
Thank you, sir. Thank you so much, sir. Thank you all the mentors, our co-faculty, all mentors. Thank you very much for successful session, completion of this session. Okay. So, would you like to say something, with Rajesh Verma garu? Mentors, please give your valuable feedback to Rajesh Verma.
Thank you, Rajesh Verma sir, and myself, Saujanya. So, on behalf of our mentors side, I would like to say very thankful to you, sir. Actually, we learned a lot. How should we prepare the students to do projects on this machine learning side? And I want to thank for your insightful presentations sir, since last 5 weeks, and really all the sessions were very informative, sir. And thank you for helping us become more aware of these machine learning problems and the ways you help us to solve them. And on behalf of our students side, really we feel very proud of that you sir, having such a knowledgeable resource person with us. And we thank our HOD sir for providing us this great opportunity to collaborate with you to learn something, and parallelly we deliver it to the students. Thank you very much, sir.
Thank you, madam, for your
Madam,
words.
one more, madam. We should thank to our management also for conducting this beautiful session.
Sure, sir. Thank you so much.
Yeah. Okay, sir. Thank you, Rajesh Verma garu. Thank you, sir, very much. Thank you very much.
And
Our mentors are also
Patanjali
get,
sir,
our mentors also get knowledge.
Actually, a lot of people are allowing us to learn something new topics from this. Actually, they are completely new to this technology, sir. But people are arriving individually and independently. They are trying to ask what is this, how to do we do projects on this. They are very interesting, sir. So for providing such an interesting those students, really we are thankful to you, sir. Uh, uh, it's like an uh, good thing happen. in this period of time. So thank you so much.
Thank you, madam. And one thing
Thank you,
is,
thank you,
like, I just
Sajana
want to
madam.
say
And Durga
that
madam, would you like to say something? Uh,
all,
Hello,
So,
Durga madam, would you like to say something? Durga madam, would you
Sir,
like to say something?
sir, thank you very much, sir. Sir, Rajesh,
yes, madam.
sir, you are saying
Okay.
something. Sir, you are saying something, Rajesh, sir.
Yes, madam. I can hear you. Yes, Durga madam. Like, I just want to say that, like, you should complete all the assignments in the beginning, and then you should go out and get some projects in the AI/ML space. Our government of India is encouraging a lot. Basically, the people who know AI/ML and DL and many of the companies are also encouraging a lot, and they want in this year, which is going to end, and in the next year also, they are going to uh, have all the faculty members, others also go and do a lot of AI/ML projects. And AI/ML is basically going to be introduced as one of the subjects which your college is also introducing, and it is being introduced in other colleges also, and students are learning this, and it's like hot cake which is basically being introduced in this particular next year to come, and it's going to stay for at least for 2 decades, 20 years, 30 years, it's going to stay. So very good that you got introduced early. I request you to basically deep dive into this particular subject of AI machine learning. And I thank the management of Potish Ramdu basically to go ahead and introduce this particular subject. And thanks to Patanjali sir and his team for basically going and introducing this particular subject. Now I request you to go ahead and do live projects in this particular space so that you get some hands-on, and then you are able to go ahead and make the difference. And good luck to all of you, and thank you very much.
Thank you so
Thank
much,
you,
sir.
sir.
Okay, sir. Thank, thank you so much, sir. Thank you so much. Our mentors will guide the students to do live projects, sir. Okay. So, and our mentors will get in touch with you through your mail ID also, sir. Okay.
Sure, sure.
Okay. Sure, sir. So, okay. Thank you, mentors. Thank you, one and all. It's time to leave now. The session. The session is completed. So, Rajesh sir, I will call you later. Okay. Today.
Oh,
thank you, sir.
thanks everyone, and all the best.
Thank you, sir.
Bye-bye.
Thank you, sir.
Thank you.
Thank you so much.
Okay. Thank you, one and all. Thank you, one and all. Bye bye.